Hello and welcome back. This is Energy System Technology Lab 2, and this week I will attempt to use my computer and my camera to explain to you how to connect an Aquastat and a primary control for a hot water system. It is going to be a little bit involved, but I have no doubt that you can do it. So let's get on with it. And we'll start where we left off last week, where we connected the primary control. And the primary control is also called the CAD control, which controls the burner. So, okay, let's move into the next slide. Okay, so the objectives of this week, we will perform the following. First, wire the same CAD control from last week in addition to a hot water control, which is an Aquastat. Then we'll follow the sequence of operation for both controls and see what happens. So we said before that the primary control, the CAD cell, controls the burner operation. And you know the burner has to do a few things, which are pumping fuel, pumping air, providing ignition, seeing the light, and reacting to the absence of the light. So it has few primary functions to turn on and off the heat, which is the fire. So it concerns only with the functions of the burner. The Aquastat, on the other hand, controls the temperature of the water, because we are using water to heat the house or to heat water or another kind of system. So, and they both can be connected together. So this time we will use a primary and an Aquastat. And you can see as we go along, we can connect many things to it. We can connect primary, an Aquastat, a switch, another switch to it, and we can also do a switchboard with more than one zone. We'll see how this goes along. So far we said we have primary control. I hope you can see this. It only controls the burner. Then we have Aquastat, and that controls hot water. Okay, I will move and add stuff to them as we go along. And the sequence of operation is very important. And see the action done on the controlled equipment using the light bulbs instead of real components. So in the lab, what we will do is what are the components coming and connected with the primary control. So the primary controls has motor and has ignition, and has valve, and what else? Basically valve, ignition, and motor. Those are the three primary controls. And Aquastat, what does it have? It has a circulator, which pumps water. And what else? That's Aquastat, circulator. And the Aquastat also controls the primary. So it goes back to controlling the primary over here. Okay, so you'll see this happening as well, and we can troubleshoot some of those issues. So if you have the Residual Heating book, it's going to be chapter 14 in the Weinberger book, but if you don't have it, it's fine. You don't have to worry about it. There's enough information to get by with this chapter. Limit controls, operating controls, and primary control. So it talks about this in the book, but we will talk about them as well. So the primary control is, we said, is the CAD cell control, which controls the burner. This control monitors the operation of the oil burner, has safety shutdown to lock out if there is no flame or the flame doesn't come out in the right time, so it does shut that out for safety. You don't want to keep igniting when there's no fire, so it detect the flame and shut off the fire, shut off the motor if there is no flame. It also have a flame detection system. Again, we said before from last semester that there are two ways to detect flame. Either you can sense the heat coming from the flame, or you can see the light of the flame. Those are the two available ways to detect the presence of flame. You can also detect the ions, but that's something we'll do in week 10 when we'll do industrial burners. There is also a way to detect and see the ions and feel the ions. Let me just make this a little bit bigger so you can see what I was talking about. Okay, primary control. It has the burner. It controls the burner and motor, ignition, and valve. This is the two controls we have. And Aquastat controls the hot water, and it goes to control the circulator, which circulates the hot water, and it controls the primary. So they are integrated in a way. Okay, I'll go back and I'll keep going back and forth between the camera and the board. So heat and light again, and with heat it's always a little bit not too fast to detect heat. If we use a bimetal to detect heat, it will take a few seconds, actually not a few seconds, sometimes over a minute to detect heat, and we'll see that when we use a stack mounted relay. So it's really not that fast. So light is the fastest way to know if there is flame or no flame. And again, we said the timing has changed for light from 45 seconds to verify light to 30 seconds, and now finally it's around 15 seconds to detect the presence of flame by light. Okay, let's move to the next slide. This here is the first, if I'm not mistaken, the first generation of primary control. It looks, it had only one button for reset, and here is the FF terminal. If you can see, it is still called the FF terminal, and that's where the CAD cell control goes. The CAD receptacle goes here. The yellow wire is going to the FF terminals, and the receptacle for the CAD cell goes in here. The CAD cell again is cadmium sulfide cell that reacts with the light. The resistance is very high during the dark and very low in the light, and this is how we detect the flame. And the TT again goes to the thermostat. You see here that the TT is jumpered, which means it's closed. What does that mean? That will put the primary control in action the whole time. So the switch is closed, so it means that there is a request for heat. So why aren't we using the thermostat here? Because in this case we are using the primary control to control using the Aquastat to control the primary control. So if we look again at this schematic here, we have the same thing. So the TT terminal in the primary control is jumpered. So the control of the primary control, when does it come back, when does it come on, comes from the Aquastat. And again, we'll see this shortly. I'm glad I have this in video so you can go back and watch it again, because this will be very, very essential for you to know how to connect a primary control and an Aquastat. Okay, this is the new modern Aquastat now. I'm gonna change where this is. Okay, I'm gonna put it here. So this is the new Aquastat. It looks a little bit different than the one we saw before. It has an LCD screen, and you'll see the 4 outside terminals still the same way. FF are here, so you're actually this is for communication. The FF are in the back here, so the CAD cell will go in here. Again, it's yellow as you can see, and also you see the TT terminals are placed over here for the thermostat. And in case you have an Aquastat, you will put a small wire between them to jumper. Okay, so I just wanted to give you a picture of what it looks like. Okay, moving on. Testing the CAD cell. I will write this down. How do you test the CAD cell? Because again, it goes bad very often, so it's good to know how to test the CAD cell terminal. Basically, the operation is very, very simple. What you do is so this is my CAD cell. You've seen it before, I mean just previously, and it has 2 wires in here. So you're going to unplug the CAD make sure the CAD cell I is plugged in, because there's a plug-in here, and you can unplug it from the primary. So you have two wires in here, and you will bring your own meter and you test the resistance, and then you put your finger in here and you test the resistance. It should be in the dark, should be more than 10,000 ohm. So this should read more than 10,000 when you plug it with your finger. When you take off your finger and you measure the resistance, it should be in the light, it should be less than 1,000. That's a big difference, right? So it should be very, very small. So again, what happens if you just take this out and you have nothing? You have only the plugs here, and this is out. You took it out. Be consistent with the drawing. So what if you took it out? What? And you try to measure. What are you gonna see? What do you think? So if you took it out, what measurement are you getting from this side? It's nothing. There's what's between those two terminals? Air. And airs have high resistance, so the resistance will be very high, which is more than 10,000. So you're gonna get infinity. It's a really large resistance, so it will pretend it's in the dark. So if you take it out, it means it's kind of in the dark, and it's going to not go on. It will think that there's no fire, but that's not testing the cell, because you have to test with the cell in, not by taking it out. So this is how you test it. You leave the cell on the receptacle. You put your finger to simulate dark, and it should be 10,000. Otherwise, take out your finger in the light, and it should be less than 1,000. Means it's working. Okay, I'll go back. This is how it should be tested, and the resistance should change. The more light you have, the less resistance you should have. It could be as low as 40 ohms if you have a lot of bright light, and it's a way to know how much fire you have inside the chamber. Okay, moving on. So steps to check the CAD cell primary control. What can you do to check if the control is working? First thing you do, if you want to know if the control is working or not, is check the power coming to it. If it's getting 120, go and check the power at the L1 and L2 terminals, and it should be 120 volt. That's the first thing you can do. Then you can also jumper the TT terminal, which means I'm trying to check see if the primary control is working or not. So first of all, I verify that it has power. Second, I'm trying to see if it's a problem with the thermostat or the primary, so I jumper the TT. So that's one thing you do, and then you can check for the CAD cell, see if it's functioning or not. Other than that, if it's still there is no function, probably the CAD primary has to be changed. Okay, electronic controls. So we have most of the controls are made by Carlin or Honeywell. Again, every company have their own primary control, so it's not very uncommon to see controls looking different than what you used to, but the main function and the main process should be the same, and also the wiring should be the same. Some of them also do not have heavy transformers, they have igniters. So again, we talked about that last semester. They do go back and forth. This is from the NORA book, so check the page 201 or 205. They might have been changed, but there is more information about primary controls and different types of them in the NORA book as well. Okay, so let's move on. So this is the Aquastat, and I want you to remember the terminals. Let's take a look at them a little bit, because that is very important. Use the pen. So let's look at the TT terminals. What goes here? The thermostat. Well, should be connected in here. What is L1? That is line voltage. L2 is neutral. Please pause if you need to, because I need you to remember those terminals. L1, L2, T, and we have C1 here. If you can see it, C1, that goes to the circulator. And I had you do that last semester, and this is going to be hot, right? And there's C2, and that's circulator neutral. B1 will go to the primary control. Where in the primary control? It will go to either the red one, that's the limit. If we have no red one, it will go into the line voltage. So B1 is going to give you hot voltage, which is 120 to the primary. It should go either to the red in the primary if you have it. If you don't, you just put it to the black. And B2 is neutral. Do you have to connect the B2 and C2 since they're neutral? You don't have to, but it's recommended. Some Aquastats will be very finicky and they need a feedback from the equipment, otherwise they might give you an error. So make sure you use those terminals. Okay, another picture of the thermostat of the Aquastat. What is this part? It's the probe, the bulb. The bulb is full of liquid that will expand with heat. So this is what actually sensing the water temperature. This goes inside the water tank and senses the temperature. And the lab will simulate the water heat by hot water and see how it will react to it. So this will be inside the water tank. As we turn on the burner, heat will be made and the water will get hot, and we have to keep the water between those two temperatures here. So we'll see the sequence of operation. But now we are monitoring the flame inside the boiler, and we are monitoring the temperature inside the water tank. Okay, this is what it looks like on the board. We will do the connection, and I will do it here on paper, but it should be kind of very similar. We remember these switches. These are the safety switches that you will see in the wall in any house. Fuse, safety switch, pneumatic switch, and another switch. There should be two switches in there. Usually this switch will be on the top of the stairs going to the basement, and this will be near the burner. So you have 4 switches before you go into the line voltage here. Okay, got it. This is the Aquastat, and we saw the terminals that we need to connect. And this thing sticking out here is the bulb. The bulb usually goes inside the water tank, but since we are trying to look at the controls all of them at once in front of us, we just laid everything close so we can understand how it works. In real life, these will be all over the place, and this will be in the tank, and the primary control that's supposed to be here will go on the oil burner. These light bulbs here are labeled. I did relabel them again now, and they do represent the motor. One of them is the motor, ignition, valve, and one of them is the circulator, so we can see what is running and what is not, and we will use one of those thermostat. So I'll do it now on paper, and hopefully you will get an idea of how it's supposed to work, and I'll go over the sequence of operation as well. Again, it's very simple, and you can pause and go back anytime you want, and please ask me questions during the hangout. Okay, this is the schematic I'll give you. This is the simple schematic of the Aquastat, and this is supposed to be the primary control. And again, this one has only 3 wires. Actually have all the wires available in it, and I know looking at it the first time it might not make sense, but once you try to connect it once or twice, you will get the hang of it. So I'm going to keep this picture in here, and I will expand on the camera. Hopefully I can move this camera. Oh, it doesn't move. Okay, so I'll let you go back and forth and look at the camera, but what I will do here is I actually try to draw. Yeah, I think it's very clear. I can see it. So this is the Aquastat, which you will see here in the back, and this is the line voltage in here coming, all the 4 switches that we saw before, and this is the CAD or primary control over here. You see the TT terminals, the FF terminals, violet, and this is the color: violet, blue, orange, black, and white. So I will go through the connection, and hopefully it will make sense. Okay, so I'll do the connection right now, and hopefully it will make sense. Let's try to focus here. So this is my line voltage coming all the way from the wall. Line voltage will fork. We need to supply line voltage to the primary control, and we need to supply line voltage to L1 here. Make sense? Both of these components needs to have line voltage. Also for the neutral needs to be connected to the Aquastat, and again neutral needs to go into the white over here. So line voltage will go to Aquastat and go to the primary, and neutral will have to come from each one of them to complete the circle. We always agree that we have to have both lines coming into the component. Now, thermostat. We're going to have a thermostat here, and this thermostat, TT, will connect to the TT terminals over here. So this is my thermostat. And since this system is going to be controlled by the Aquastat, what I'm going to do for the TT here, you're going to put a jumper between them. That's a jumper, small wire. Hopefully this makes things a little bit clear. What about the FF terminal? The FF terminal will go into the CAD cell control. The yellow wires, this is the receptacle, and this is the CAD cell, FF. Okay, and the rest is just easy. The orange will go into the motor. Orange will go into the motor. Blue will go into the ignition, and violet will go into the valve. And these components are all actually available on the burner. The burner had a valve, remember, it had a motor, it had the ignition. We did take those apart and put them back. Now, don't forget that there's a neutral that has to come out of each one of those components. So neutral will come all the way to here, and to here, and to here. This is a connection over here. And if you have neutral terminals in the back, you can use them and just connect to them. Okay, what about here? We have a circulator. This is going to be circulator. This is hot, and this is neutral. Okay, and now this thing customarily will have a red line here. It's called limit, and it's red, and this will go into B1. You don't have to connect the B2, but if you want, you can. If it doesn't have this limit, then what we will do is, if there is no limit, then you will connect the black not to the hot, but it's going to go all the way into B1, and the neutral can stay wherever it is or can go into the B2. The point being is, the primary control need to get either can be in standby with the black over here, and the B2 will tell it when it's turned on or not. If it doesn't have that option, it cannot turn on until the Aquastat says so, because the Aquastat is monitoring the temperature of the water. Okay, I know it seems a little bit confusing right now, but if you think about it logically, it makes sense. So what is the sequence of operation of this little setup here? So first of all, the thermostat will call for heat. The Aquastat will check the water temperature. If it's within limit, it will turn on the circulator, and hot water will circulate through the house until the heat is satisfied, and we're happy. If the thermostat calls for heat and the water is not within limit, it will send a signal to the primary control to make some heat, make some fire. Okay, so this then, and the circulator will not turn on, it will just wait. The primary will check the flame inside the chamber. There's no flame. Okay, so it will turn on the motor and the ignition, wait for 15 seconds, then turn on the valve, and suddenly we have flame. We got flame. We will keep the flame on, so we're good, and we shut off the ignition. We keep the flame going until the water is hot. We have the I'm pointing to the switches here. Remember the switches? These are the high and low limits connected to the bulb. So if there is no switches, so now it's heating, and the water temperature eventually got to the between the limits, and the circulator turned on, and we're good. So the circulator turned on, the thermostat is satisfied, then the circulator is off, and this will turn off. It's okay. This is the sequence of operation. But what happens if we try to turn on the flame and there is no flame? The system will stop and try again in 15 seconds, and it will do that 3 times, and otherwise it will just go in safety, and we have a hard lockout, and you have to go and press and hold the button for a minute. But it's important for you to check why did it go in safety before you do the reset. Okay, let me go back to my regular view. Again, these are the terminals here, and you can see the limits. Hold on, the limits over here. It's not trying to draw. Okay, it's not drawing, but this is the limit, high and low, and this is my line voltage, and these are the connections, and you see we have the extra L2s in here. Okay. Fact checks. What are the 2 methods to detect flame? We said either heat or light. What is the best way to replace defective control? The best way to replace it is to get the same exact model if you can. If not, try to get the new ones, but you have to kind of know how does it connect. In a CAD cell, what is the maximum allowable safety timing for residential systems? I did mention that last week, and we said it used to be 45 seconds, and now it is 15 seconds. What happens if to the CAD cell resistance when it sees the light? It becomes lower than 1000 ohm. What is the resistance of the CAD cell in the dark? More than 10,000 ohms. If the CAD cell terminals are disconnected, will the burner start? Think about that for a second. Yes, it will start because it will think it's dark, because it has no resistance to measure. But it will turn off in safety in 15 seconds because after it turns on and there's no fire in 50 seconds, it will think that the system failed. So yes, it will turn on, but it will go back in safety. If the CAD cell terminals are jumpered, will the burner start? No, it will not start, because if it's jumpered, that means it has low resistance, which means that there is fire, which also means if there's fire, why are we starting the system, right? Doesn't make sense. Okay, what does a safety lockout do? What it does is it prevents anything from working. Nothing will get power, just to have the technician come and visit to see what's happened. Why did we try for 3 times and there is no fire? Okay, again, we're dealing with ignition, with fire, with fuel. So it's very unsafe to have this to work when there's no, when it does not work as we expect it to be. Okay, some definitions that you need to know, very important. For hot water control system, integrated system, that's when the thermostat controls the operation of the burner and circulator. That's integrated system. The thermostat controls the operation of the aquastat and the primary control. Non-integrated, thermostat controls circulator only, meaning that the thermostat has no control over the water temperature, only the circulator, to on or off. Differential range is the operation temperature of the aquastat. The operation of the aquastat control, high limit control turns the burner off if the temperature is too high. Low temperature turns the burner on when the temperature is too low. Circulator control turns on the circulator pump when the boiler temperature is up. Warnings. Take the warnings on the labels and manuals seriously. If they put a warning there, trust me, it's for a reason. So do not disregard warnings that comes on the equipment. Never ever plug the board without checking with the instructor in the lab, because chances if you put 2 hots where they're not supposed to be, it can cause a spark and it could be scary. So please check with me or whoever is doing the lab before you check it. Again, try to curb your enthusiasm. Don't get too excited and just go unplug right away. Make sure you check every connection and make sure it's sound and it's not flimsy, because again, we're dealing with 120 volts and it can be a little bit painful if you get zapped. When trying to produce heat with the a torch or a candle, use care in terms of time and location. That's we used to do that in the past. We used to try to test the bulb, the sensor bulb, with either a small candle or a torch. And I'm not doing this anymore. You're not supposed to do it anymore. Now we use hot water. We actually have a water boiler next to in the lab, so we can use hot water being boiled, which is more reasonable than using a torch. Even in the field, if you use a torch or a candle, you cannot distributing the heat equally throughout the bulb. It was designed to sense a water temperature, not flame. Be patient, better be safe than sorry. Do not rush the job. Make sure all the connections are sound and double check the wiring and make sure it makes sense. Again, I cannot emphasize this much. Make sure you check your neutral, that every component has a neutral. The motor has a neutral. The ignition has a neutral. Everything that has a power needs to have a neutral. Take joy and pride in your job, meaning that don't do a flimsy job or something where the wires are all over the place. Try to keep things neat as much as possible. Alright, thank you, and I will post this video on Blackboard, and I will post the questions on Blackboard as well for this lab to do. Thank you very much, and have a good day.